Hi young friends, in this video we are going to discuss different mathematical expressions of simple harmonic motion. Okay, so in previous video we came across the mathematical expression for oscillator motion. What is that expression? F equal to minus k into x power n. N takes 1, 3, 5, 7, etc. Any odd integer. Am I right? F equal minus k into x power n. Now coming to first parameter, force. Force. If n takes least value, that is 1, then what about the mathematical expression for force? That is F equal to minus k into x. So this is what simple mathematical expression for simple harmonic motion. SHM. Simple harmonic motion. So whenever n becomes 1, it takes the form of F equal minus k into x. So that's about force. Here k means force constant. Why to take negative sign here? Means force is always opposite to the displacement of the particle. Am I right? F equal minus k into x. Alright. Now if x equal 0, what about force? F equal to minus k into 0, that is 0, right? So whenever particle is at its natural position during oscillation, no need of restoring force, therefore F equal to 0. Similarly, if x equal to plus a, means if particle lies at its extreme position towards positive end, that is F becomes minus k into a, right? If x equal to minus a, that is when particle lies at negative extreme position, then F becomes equal to minus k into minus a, that is plus k. Minus k into minus a, that is plus k, right? Similarly, acceleration. Coming to acceleration, next point, acceleration. Acceleration equal to, what is acceleration? A equal to F by m. F means what? Minus k x divided by m. So a equal to minus k by m means minus of k by m in the sense omega square. So omega square into x. Since k by m equal to omega square. K means force constant, m is mass of the oscillating particle. So omega means angular frequency. Right? A equal minus omega square into x. Okay. So in the same way, during the oscillation of the particle, its position changes continuously. So as per position, here acceleration also changes. Means here acceleration is non-uniform. Force also non-uniform. Position dependent. Here also acceleration position dependent. So if x equal to 0, means when particle is at its natural mean position, then what about acceleration? A equal to minus omega square into 0, that is 0. No need of acceleration. Why? Because at x equal to 0, force, restoring force is 0, implies that acceleration also 0. In the same way, if x equal to plus a, okay, positive extreme position, when particle lies at positive extreme position, then acceleration equal to minus omega square. See here, minus omega square into x, that is minus omega square into a, right? So what is the maximum displacement for oscillating particle? Amplitude. So therefore minus omega square into a is nothing but a max, that is a max. Similarly, if x equal to minus a, when particle lies at its negative extreme position, that is acceleration becomes equal to a equal to minus omega square into minus a, that is plus omega square into a. This one also maximum, a max, a max. Alright, here same can be represented diagrammatically. Suppose this is the mean position of the particle. This is what positive extreme position plus a. This is what negative extreme position minus a. Suppose particle is oscillating along x-axis. That is either side of mean position like this. Okay. So when x equal to 0, what about force and acceleration? Force equal to 0. acceleration also equal to 0. So at x equal to 0, force 0, restoring force 0, acceleration also 0. In the same way, when x equal to plus a, when x equal to plus a, force becomes minus ka, acceleration also minus omega square into a. That is force equal to minus ka. Minus k in the sense this is the direction of force. Minus k towards negative x-axis. In the same way, what about acceleration? When at x equal to plus a, acceleration also equal to minus omega square into a. So acceleration also equal to minus omega square into a. Right? So both F and acceleration directed towards mean position. That is towards negative x-axis in both cases. Now coming to third option. When x equal to minus a, that is when particle lies at its negative mean position here. What about force? F equal plus Ka. F equal to plus Ka. Acceleration equal to plus omega square into A. Acceleration equal to plus omega square into A. A means what? Amplitude. Amplitude. See, this is what amplitude. From mean position to extreme position, the length of the path becomes amplitude. That is what maximum displacement. Here also, from mean position to negative extreme position. Otherwise, from mean position to positive extreme position, the path is equivalent to amplitude, right? Capital A. So here, what is the direction of force and acceleration when it lies at negative extreme position? See, plus Ka. Here also plus omega square into A means both are positive in the sense rightwards. Both F bar and acceleration A bar directed along positive x. Here both directed along negative towards negative x-axis. So ultimately we can say that both force and accelerations directed towards mean position. Both force and accelerations directed towards mean position, irrespective of direction of motion. These two point is always directed towards mean position, right? Okay. In the same way here, F is directly proportional to minus x. F is directly proportional to minus x. Here also, A is directly proportional to minus x. So F is proportional to minus x. A is also proportional to minus x. In the same, that means acceleration is directly proportional to displacement of the particle from the mean position, right? But directed opposite to the displacement. Here, displacement, how to measure displacement of the particle in case of oscillation? Always the displacement is to be measured from the mean position. Suppose this is the mean position, particle is somewhere here at extreme position, for example. It moves for a while and comes to this position. Now what is the displacement here? If origin is x equal to 0, that is we are measuring all measurements, that is we are measuring displacement of the particle from the mean position, not from the starting point of the particle. So even though it covers this much of distance, we have to consider displacement from mean position to the given position of the particle. So this is what displacement. Okay, when it moves from extreme position to this position, displacement becomes this segment, not this segment. Okay, that's what I want to tell you, right? So next one. So force is directly proportional to minus x. Acceleration also directly proportional to minus x, right? So this is what one of the characteristics of simple harmonic motion. Both force, acceleration is both are directly proportional to displacement. One more thing, both force and accelerations directed opposite to the displacement. This is also another characteristic of simple harmonic motion, right? One more thing, motion must be periodic. Motion must be periodic. This is also one of the conditions for a particle to exhibit simple harmonic motion, right? Now coming to variation, how force varies with x, how acceleration varies with x. That is what x means, position of the particle. See, if x is positive, f becomes negative. If x is negative, f becomes minus or minus positive. Here also, if x is positive, a becomes minus or plus. That is negative. If x is negative, a becomes minus or minus. That is positive. That's why say one can represent the variation of acceleration, variation of force with position. Right? If x is positive, f is negative. X is positive means f negative in the sense like this. A straight line in the fourth quadrant. If x is negative, f becomes minus or minus positive. If x is negative, f becomes positive means we can find the straight line in the second quadrant like this. Like this. Am I right? Okay. Now, if this is the extreme position, for example, this is what x equal to plus a. This is what x equal to minus a. This is what x equal to 0. Origin. Right? Origin. Now, at x equal to 0, force equal to 0. X equal to 0 means force equal to 0. Right? Next, if x equal to plus a, f equal to minus k. X equal to plus a here. X equal to plus a. F becomes minus ka. F equal to minus ka. If x equal to minus a, f becomes plus k. X equal to minus a, f becomes plus k. Plus ka like that. Now what about slope here? Slope equal to m equal to y coordinate divided by x coordinate. Otherwise, change in y coordinate by change in x coordinate. That is f by x equal to minus k. F by x, that is minus k. Minus k in the sense minus k means m omega square. K means what? M into omega. See here. K by m equal to omega square. K equal to m omega. That is minus m omega square. Okay. In the same way, one can plot variation of acceleration with position. See here, acceleration equal to minus omega square into x. So, in the same way, acceleration is taken along y-axis and position is taken along x-axis like this. Position along x. Right? So, variation of a with x. Now, see, when x equal to 0, acceleration 0. Right? Next, when x equal to plus a, acceleration equal to minus omega square into a. Means here a acceleration is proportional to minus x. Acceleration is proportional to minus x. Means x positive, acceleration negative, x negative, acceleration positive. Means we can find variation in the same way as in the previous case. That is like this. Like this. See? This is what x equal to plus a. This is what x equal to minus a. Right? When x equal to plus a, what is acceleration? Minus omega square into a. Minus omega square into a. When x equal to minus a, acceleration equal to plus omega square into a. X equal to minus a, acceleration equal to plus omega square into a. Right? So, during the oscillation of the particle, simple harmonically, we can find both force and accelerations maximum at extreme positions and minimum at mean position, right? Minimum at mean position. Now coming to variation of velocity with x. How velocity of the particle varies with position. Okay. So to get the relation, you have to consider the expression acceleration equal to minus omega square into x. Minus omega square into x like this. Third point, acceleration over, and third one, velocity. Third point, velocity. Velocity of oscillating particle. Velocity of oscillating particle. So which oscillate? simple harmonically. So we know that A equal to minus omega square into x. Acceleration equal to minus omega square into x. Now how to replace acceleration here? If you want to get variation of velocity with x, A should be replaced by v into dv by dx. Acceleration equal to v into dv by dx. V into dv by dx. That is minus omega square into x. Why it is v into dv by dx means suppose if a equal, since here see a equal to dv by dt, we know that acceleration equal to dv by dt, that is it is multiplied and divided by dx, that is dv by dt into dx by dx. Now see dx by dt, dx by dt, this is grouped into dx by dt into dv by dx, dv by dx. Now dx by dt means what? Velocity. dv by dx as usual. So acceleration also equal to velocity into dv by dx. Acceleration is dv by dt, otherwise velocity into dv by dx, v dv by dx. So as per the situation, one can take dv by dt, otherwise v into dv by dx. So here we need to find variation of velocity with the position. That's why a should be replaced by v into dv by dx. Okay, v into dv by dx. Right? Now after rearrangement, here we have v dv equal to minus omega square into x into dx. Right? v dv equal to minus omega square into x into dx. Now this expression saying that in every dx the change in velocity becomes dv. Now if you want to get variations in large scale, we have to integrate the expression, that is integral v dv equal to minus omega square into integral x dx. Integral v dv equal to minus omega square into integral x dx. Okay. Now x dx, suppose at extreme position, let me say that particle is initially at extreme position, positive side, that is plus a. Eventually it reaches a position x. Am I right? So what are the limits here? A to x. When particle is at extreme position, positive extreme position, what is the speed here? 0. Eventually when it reaches, see here, when it lies at extreme position, positive end, speed is 0. Speed 0. Eventually it reaches somewhere here or here or here. So at that place, what is the velocity of the particle? Let it be v. Let it be v. So when position x equal plus a, velocity is 0. When position x equal x, velocity becomes v. Those are the limits which we are going to consider. Am I right? Now integral v dv means v square by 2 at limits 0 to v minus omega square into integral x dx means x square by 2 limits a to x. Now 2 and 2 gets cancelled. We left with v square. Under limits v square, limits means v only. Therefore v square minus lower limit 0 equal to minus omega square into x means what? X only. So x square minus x means here a. So a square. So I'm taking limits. It takes the form like this. Right? Now v square minus 0 equal to minus omega square into x square minus a square. Now v square equal to omega square into a square minus x square. Why? Because a is greater than x. So x less than or equal to a. That's why a same can be written as omega square into a square minus x square. Implies that v equal to omega and root over a square minus x square. So this is what variation of velocity of the particle which is under SHM or simple harmonic motion with position. See variation of v with position x. Now how to find this variation? Mathematical means graphical. How to find the variation with position x graphically means, now I am taking like this. For example, if I take like this, I am squaring v square equal to omega square into a square minus x square. So v square by, see here, v square by omega square equal to a square, v square by omega square equal to a square minus x square. That is v square by omega square plus x square equal to a square. V square by omega square plus x square equal to a square. Now v square by omega square plus x square whole by a square equal to a square by a square means expression is divided by a square on both sides. Now a square by a square becomes 1. So x square by a square plus v square by omega square into a square. So same can be written as x square by a square plus v square by omega square into a square equal to a square by a square means 1. A square by a square means 1. So this is what variation of velocity with x. So this is nothing but ellipsoidal equation. So mathematically this is equivalent to ellipse, right? Means how velocity of the particle varies with the position. Let us discuss, right? Let us discuss here. This is what ellipsoidal variation of velocity with the position. Am I right? So x square by a square plus v square by omega square a square equal to 1. If at all, if omega equal to 1, the same can be written as x square by a square plus v square by a square equal to 1. So x square by a square plus v square by a square equal to 1, provided angular frequency of the oscillating particle is 1, that is 1 radian per second. So implies that x square by a square plus v square by a square equal to nothing but circle. Expression for circle. Okay. Expression for circle. See how it varies. Suppose particle lying at x equal to 0 means when it lies at the main position. What is the speed of the particle? Omega into a. Why? Because see here, we know that v equal to omega into root over a square minus x square. V equal to omega into root over a square minus x square. V at x equal to 0, that is when x becomes 0, that is when particle reaches its main position. So x 0 means omega into root a square, that is omega means v max, maximum speed. When particle reaches its main position during oscillation, its speed is maximum. In the same way, v at x equal to plus or minus a means when it reaches positive extreme position, otherwise negative extreme position. In both cases, if x equal to plus a square minus a square. If x equal to minus a square minus of minus a whole square. So in both cases, v becomes equal to 0, minimum. Why? Because during the oscillation, suppose it moves from main position to extreme position, it is under retardation, means speed gradually decreases and becomes 0 at extreme position. Here also, from main position to negative extreme position, what happens? Speed decreases and becomes 0. Why? Because force is directed towards main position, but direction motion is opposite. Here also, force is leftwards, but direction motion is rightwards. Therefore, when it moves either side of the main position, particle is under retardation. So, speed gradually decreases and becomes 0 when it reaches extreme position. Am I right? Extreme position. So in the same way, now we can calculate the variation like this, graphically. Suppose see here, this is what variation of velocity of the particle with position x, for example. When particle lies at mean position, what is the What is the speed here? Omega a. That is maximum. Let it be represented somewhere here. Omega a. Omega a. Right? In fact, v equal plus or minus omega into root over a square minus x square. In derivation, we have v square equal to omega square into a square minus x square. Implies that v equal plus or minus omega into root over a square minus x square. Right? So, at mean position, v max equal to plus omega a. When it passes mean position, right? Rightwards, v becomes plus omega a. So gradually speed decreases and becomes zero at extreme position. So speed decreases and becomes zero at x equal to plus a. Right? Again, it retraces its path from past to extreme position to mean position. Again, speed gradually increases and becomes maximum. But see the direction motion leftwards. Therefore, speed means velocity gradually increases and becomes zero. That is but minus omega into a. Right? Next, when it crosses mean position, it enters into the left side of the path like this. Means what is the direction motion here? Leftwards. But speed gradually, that is velocity gradually decreases and becomes zero at negative extreme position like this. Right? Becomes zero at x equal to minus a. At x equal to minus a. Again, particle tries to reach mean position after reaching negative extreme position. So again, it moves towards mean position. Means again velocity gradually increases and becomes maximum. Increases becomes maximum like that. See, this is the variation of velocity with position x. Right? So when it is at mean position, once it is omega a, one more time it is minus omega a. Why to have different signs here? Means based on direction of motion. If it crosses rightwards at mean position, v becomes plus omega a. If it crosses mean position leftwards, then speed becomes minus v max equal minus omega a. See here arrow mark. It crosses rightwards at mean position, that is plus omega. It crosses the mean position leftwards, it becomes minus omega. So that's what the difference between these two, right? Right? And here at x equal to 0, velocity equal to 0. See the coordinate 0, 0, 0, 0. At x equal to minus a, see the coordinate 0, 0. Okay. Suppose if omega equal to 1, what about variation? The elliptical shape modified into circular shape. See, like this. Circle. This is what velocity. This is what position x. Now this is what plus a. This is what minus a. X equal to minus a. Right? Now what is the maximum speed here? V max equal to omega a. That is, what is omega? Omega equal to 1. In case of circle, omega becomes 1. That is 1 into a. That is a. So velocity also numerically equal to amplitude. Here amplitude also plus a. Here amplitude minus a. Here what about velocity here? That is again minus omega into a. That is omega means what? 1. That is 1 into a. That is minus 1a. That is a. Minus a. Right? So when omega equal to 1 radian per second, velocity varies with x as shown here. See here, the variation is circle. Here variation is elliptical. Right? So that's about variation of velocity with position x. Right? Now let us see one illustration. See, suppose one particle is oscillating simple harmonically with velocity, variation of velocity with position is given by v equal to root over 144 minus 16 x square. Now find a max. What is the maximum acceleration of the particle? See, the given expression is v equal to root over 144 minus 16 x square, right? That is, we have to convert the given expression into usual form. What is the variation of velocity with position? That is v equal to plus or minus omega into root over a square minus x square. Now try to get that form. Here, see the multiple. What is the multiple of x square here? 1 more. Here also should be 1. But 16 is there. We have to eliminate 16 here. That is 144 in the sense 16 into 9 minus 16 into x square. Now 16 is kept outside and taking outside it becomes 4. 4 into 9 minus x square. That is 4 into root over 9 means what? 3 square. See the form here. V equal to plus or minus omega into root over a square minus x square. Instead of a square here 9 is there. So therefore it can be written as 3 square minus x square. On comparing with v equal to plus or minus omega into root over a square minus x square, a becomes 4. Sorry, a becomes 3. Omega becomes 4. X is position. So on comparing with the expression v equal to omega into root over a square minus x square. Now what about amplitude? Amplitude equal to 3 meters for example, or 3. Next omega equal to 4. Omega equal to 4. Right? Now what is maximum acceleration? What is the expression for acceleration? Now only we came across acceleration. Maximum acceleration plus omega square into amplitude, otherwise minus omega square into amplitude. If you take modulus a max becomes equal to mod of omega square into a. That is a max modulus of maximum acceleration equal to omega square into a. Here also on taking modulus it becomes positive. That is omega square into amplitude. Omega square means 4 square into amplitude means what? 3. That is 4 4 just 16 into 3. That is 48 meter per second square. 48 meter per second square. So that's how one can find unknown quantity maximum acceleration if you are given variation of velocity with the position mathematically, right? Now coming to one more numerical based on elliptical variation of velocity with position x. Suppose you are given a graph representing variation of velocity with the position like this, right? This is what elliptical variation of velocity of oscillating particle with position x. Suppose here the value of velocity is 0.6 meter per second. Here the value of x equal to plus 10 centimeter. Here the value of x equal to minus 10 centimeter. And comparing usual diagram, see this is what positive amplitude, this is what the coordinate negative amplitude. So what is the amplitude here? A equal to 10 centimeter. A equal to 10 centimeter. Now what is this value? 0.6. 0.6 in the sense V max. This is what V max. So what is the maximum speed of the particle when it reaches mean position? Means 0.6 meter per second. So it reaches or it crosses mean position every time with a speed of 0.6 meter per second. That's what maximum speed. So this is what V max. V max. So the given value 0.6 meter per second is maximum speed. Now what is the expression for maximum speed? V max equal to V max omega into A. Right? In fact, plus or minus omega into A. If I take modulus, mod V max equal to omega into A. That is, omega means 2 pi by T into amplitude. Right? Into amplitude. Now V max means 0.6. 0.6. See here, 2 pi by, that is omega means 2 pi by capital T into amplitude. Now here what is unknown quantity? Find the time period of the oscillating particle. See here we have maximum speed 0.6 meter per second and amplitude 10 centimeter. So one can find time period. So T equal to 2 pi by mod V max into amplitude. That is 2 pi by V max means 0.6 meter per second into amplitude. What is amplitude? 10 centimeter means 1 by 10 meter. 1 by 10 meter. So 0.6 into 10, that is 6. 2 pi by 6, that is pi by 3 seconds. Pi by 3 seconds. So that's how one can find time period also, right? Now, next point, different forms, mathematical forms of simple harmonically moving particle, right? Suppose during the oscillation of the particle, like this, during the oscillation of the particle, how to represent the motion of that particle mathematically. Suppose when it reaches mean position, it takes one form. When it reaches positive extreme position, it takes another form. When it reaches negative extreme position, it takes one more form like that. So at different positions, the equation will be different. How to find simple harmonic equations for the oscillating particle, right? Now let us see. Let us consider variation of velocity with position. What is this? V equal to plus or minus omega into root over a square minus x square, right? So we have to consider this expression. Making use of that expression, one can find mathematical expression of simple harmonic motion, right? See here, mathematical expression, different forms of SHM, mathematical forms. See, V equal to plus or minus omega into root over a square minus x square, right? Now, V means what? Dx by dt equal to omega plus or minus omega into root over a square minus x square. That is dx by root over a square minus x square equal to plus or minus omega into dt. Dx by root over a square minus x square equal to plus or minus omega into dt. Now how to replace dx and x? Means we know that x equal to a sin theta and dx becomes a into cos theta into d theta. And differentiating, x becomes dx, sin theta becomes cos theta into d theta. That's how variation of x with theta. See, x equal to a sin theta, differentiating dx equal to a cos theta into d theta. So replace here, x means a sin theta, dx means a cos theta into d theta, right? That is, see, in every dt, what is the change in position of the particle dx? If you want to get variations in large scale, we have to integrate. So on integrating like this, between two limits, suppose at t equal 0, what is the position of the particle? Let it be initial position xi. At t equal t, at some instant t, what is the position of the particle? xf, final position, right? Now replace dx with a cos theta into d theta. So integral xi to x final. Dx means a cos theta into d theta divided by root over a square minus x square means what? A sin theta whole square, that is a square sin square theta equal to plus or minus omega into integral dt from 0 to t, right? See here, a square is kept outside, it becomes a into root over 1 minus sin square theta means again cos theta. So a cos theta root over a square minus a square sin square theta cancel with each other. We left with d theta only. So integral d theta means theta limits xi to xf equal to plus or minus omega into integral dt. Integral dt means t, otherwise integral dt leave as it is, that is integral dt from 0 to t, right? Now theta means what? Theta means sin theta x by a, theta equal to sin inverse x by a from this relation. See this relation. So x equal to a sin theta x by a, theta equal to sin inverse x by a. So sin inverse x by a under limits initial position to final position equal to plus or minus omega into integral dt 0 to t, 0 to t, right? So this is what general expression. Sin inverse e once again x by a, sin inverse x by a limits under limits xi into xf equal to plus or minus omega into integral dt under limits 0 to t. So rubbing off to have different situations during the oscillation of the particle. At main position, at positive extreme position, at negative extreme position. How this equation can be modified at different positions of the oscillating particle. Okay, at different positions, the same expression takes different forms. Okay, right? Now, different forms. I'm writing the same once again. We know that sin inverse x by a under limits xi to xf equal to plus or minus omega into integral dt limit 0 to t, right? So this was number 1, equation number 1. Now let us discuss or let us consider this position of the particle initially. Suppose during oscillation particle reaches or crossing the mean position when our observation starts, means when t equals 0, let x equal 0 be the position of the particle, and at t equal t, let x be the position of the particle. So that's what we are going to discuss, the situation which arises during the oscillation of the particle, right? So first situation, what is it? Case 1, number 1, when t equals 0, what is the position? X equals 0. Of course, particle is under oscillation, but when our observation starts, when we take the look initially, when we took the look initially during the oscillation, that's what initial instant. During the oscillation, when it reaches mean position, when it crosses mean position, I have witness of the particle. Okay, so when t equals 0, x equals 0, right? xi equals 0. When t equals t, xi equals 0 means xf equal to x. This is what the required situation, right? So when particle crossing the mean position, I have the initial witness of the particle. So that's what the situation here. Now 1 implies, modify the expression sin inverse x by a and limits. What are the limits here? Integrating limits, that is xi means 0, xf means x, 0 to a. That is plus or minus omega into integral dt means what? T, limits 0 to t, 0 to t. Am I right? Okay, that is on substitution of limits, sin inverse upper limit to x means x only, x by a, minus lower limit to 0, so 0 by a means 0, equal to plus or minus omega into upper limit t minus lower limit 0. That is sin inverse x by a equal to plus or minus omega t. Sin inverse x by a equal to plus or minus omega t. Plus or minus omega t. Right? Now what about x here? X equal to a sin x equal to a sin plus or minus omega t. See here we have two options here for the expression x equal a sine plus or minus omega t means when do we have positive sign, when do we have negative sign. Suppose during the oscillation, see during the oscillation along x-axis, if it crosses the mean position rightwards, x equal 0, if it crosses the mean position rightwards, what is the expression here? A sine plus omega t. That is x equal to a sine omega t. Right? A sine omega t. Like. Okay. If it crosses the mean position leftwards like that, then we have to go with negative sign. That is a sine of minus omega t. Sine of minus omega t means minus sine omega t. So therefore ultimately we have negative sign for the displacement. That is x equal to minus a sine omega t. Minus a sine omega t. So that's what required expressions when the particle crosses the mean position. So one expression is with the positive sign, another expression is with the negative sign. So if it crosses the mean position rightwards, then go with positive sign. If it crosses the mean position leftwards, go with the negative sign like that. So this is what required relations. Right. Now coming to next one. Next situation. What is that situation? T equal to 0. When t equal to 0, let x equal to plus a be the initial position of the particle. Initial position. Right. Number 2. Situation number 2. At t equal to 0, xi equal to plus a. At t equal to t, let x be the x be the final position like that. So during the oscillation, initially particle is at right extreme position. Now modify the expression here. One implies sine inverse x by a at limits xi to xi. Xi means what? Plus a. Xi means x. Plus a here to x. That is plus or minus omega into t limits 0 to t. Now sine inverse upper limit x only, x by a minus lower limit a. So a by a. See here instead of x we have to consider a. A by a means 1. Sine inverse 1 equal to plus or minus omega into t minus 0. That is sine inverse x by a, sine inverse x by a minus, what is sine inverse 1? That is pi by 2. Pi by 2 equal to plus or minus omega into t. Now sine inverse x by a equal to pi by 2 plus or minus omega t. Pi by 2 plus or minus omega t. So therefore ultimately x equal to a sine pi by 2 plus or minus omega t. Sine pi by 2 plus or minus omega t means, if sine pi by 2 plus omega t means cos omega t, sine pi by 2 minus omega t also cos omega t. Therefore x equal to ultimately a cos omega t. This is what required expression. So this is the valid expression when particle initially found at positive means right extreme position. So and this is what x equal to plus a and t equal to 0. So particle initially found at right extreme position. So that is equivalent to say that the particle starts from right extreme position. Particle starts its motion from right extreme position. In that case, we have to consider x equal to a cos omega t. So here x equal to a cos omega t. That's what valid expression when it found initially right extreme position. So x equal to a cos omega t. And third option, suppose when t equal to 0 means initially particle was found at x equal to minus a, negative extreme position. Now what is the valid expression here? Naturally it becomes x equal to minus a cos omega t. Let us see here. Let us see. Number 3, question number 3 or point number 3, when t equal to 0, xi equal to minus a, xi equal to minus a, that is when t equal to xf equal to x. Now 1 implies sin inverse x by a, limits minus a to xf, x. See, xi means minus a, xf means x. That is sin inverse x by x means x only, x by a minus sin inverse minus a by a, minus a by a. See once again. So on substitution, we will get sin inverse x by a minus sin inverse x means what, minus a. Minus a by a means minus 1 equal to plus or minus omega into upper limit t minus lower limit 0. Right? Lower limit 0. What is the next step here? Sin inverse x by a minus sin inverse minus 1. Sin inverse minus 1 means naturally 3 pi by 2 or 5 pi by 2, etc. So I am taking 3 pi by 2 equal to plus or minus omega. Am I right? Now sin inverse x by a equal to 3 pi by 2 plus or minus omega. On making subject x, x becomes a sin of 3 pi by 2 plus or minus omega. What about the sine of 3 pi by 2 plus or minus omega t means? That is sine 3 pi by 2 means 270. Sine of 270 plus omega t means minus cos omega t. Sine of 270 minus omega t minus cos omega t. So ultimately it takes the form of minus a cos omega t, minus a cos omega t. Means when it was employed here means during the oscillation of the particle, say this is what x equal to 0 for example, this is what x equal to minus a here. When particle was initially found at t, x equal to minus a means when t equal to 0, particle is somewhere here, right? Initially, then what is the valid condition, valid expression mathematical means here when particle reaches here, it tries to move rightwards. So this is what rightwards. So x equal to minus a cos omega t, right? Minus a cos omega t, right? Like that. So ultimately, one can compare all in one diagram what we have discussed so far at different situations while passing through main position, while reaching right extreme position, while reaching left extreme position, all can be visualized in one diagram like this. See, this is what path of the particle which is under simple harmonic motion, right? This is what x equal to 0, this is what x equal to plus a, this is what x equal to minus a, like this. A particle was initially found at t equal to found at x equal to 0. What is the valid condition? Means the particle found at mean position but crossing mean position rightwards. Then what is the valid expression here? X equal to a sin omega t, right? If particle was found at the same position and moving leftwards, then what is the valid condition here, valid expression here? X equal to minus a sin omega, right? Suppose a particle initially found at right extreme position. Now what is the valid expression here? Is like this. So x equal to a cos omega t, like this. If particle was initially found at negative extreme position, see when t equal to 0, if this is the position of the particle, now it tries to move rightwards, therefore valid condition, valid expression is x equal to minus a cos omega t. So here mean position, at mean position rightwards plus a sin omega t, at the same position leftwards minus a sin omega t, at right extreme position x equal minus x equal plus a cos omega t, at negative extreme position x equal minus a cos omega t. Am I right? Same can be visualized along y-axis also. Suppose the particle not moving along x but moving along y-axis. Same can be represented even along y-axis also. See here, this is what y equal 0. This is what y equal to plus a. This is what y equal to minus a. Right? So this is the oscillation of the particle like this, vertical. Right? At y equal 0 means mean position. If it cross the main position upwards, now what is the expression? Y equal to not x. It's not x. Now it is y. So instead of x, take y. Y equal to a sin omega t. A sin omega t. If it cross the main position downwards initially, y equal to minus a sin omega t. When t equal to 0. Right? Suppose if it reaches upward extreme position initially, that is when t equal to 0, if it found somewhere here, so what is the expression here? Y equal to a cos omega t. Simply replace x by writing y, that's all. Why? Because it is moving along y-axis, that's why. So in the same way, initially if it is found at lower extreme position, now same can be written as like this. See, y equal to minus a cos omega t. So that's about different mathematical expressions for particle while moving along x-axis or y-axis. So at different positions we have to consider different expressions while calculating sums, etc. Okay, if it is at x equal to 0 rightwards, this expression; at x equal to 0 leftwards, this expression; at x equal to plus a, go with this relation. If x equal to minus a initially, so go with this relation. Okay friends, so we will meet in next video. Thank you.